And we've got plenty of time, so don't worry about the break. I'm going to extend it a bit, so if basically no need to rush. Okay. Good morning, everyone. How are we doing this morning? I think we're going to get started. I hope everyone enjoyed dinner last night and is feeling excited and energized for our final morning of the event. Today we have a few fun things happening. We're going to start with the key transparency talks, which should be good fun. Then we'll have a little break out there as usual. You're used to this by now. And then after that, we will have the quiz. To entice you to stay for the quiz, the prizes they're looking pretty good. We have 5 prizes. First place to 5th place will get prizes. All of them include some sort of traditional Swedish sweet treats. And then first, second, third gets a tiki. And then first place gets, in addition to the normal tiki, they get a tiki unlocked and a tiki programmer board. So very exciting quiz prizes, so stick around for that. We're hoping you're going to enjoy the questions that we had quite a lot of fun putting together last night. Philippe's just started laughing because he was there for part of that.
Because the first prize also includes...
I've only just been told about this. If you would like to take Martin home, you may. So yeah, that should be fun. Then after that, we have our unscheduled lightning talks session. We do have 9 talks already signed up. We probably have space for a few more. If anyone wants to sign up, let me know. It may be that actually, if we have extra time, you can just in the spur of the moment join the queue, so to speak, and hop on at the end of that session. And then we will close. I will say a little bit more at the end. And then we will all go home and miss each other until next year. Wow, there was something else I was meant to say. Yes, one thing, on the topic of Cardboard Martin, if anyone has photos from last night of themselves with Cardboard Martin, I was aware of various people taking photos. Could you send them to me? Email them is fine, on Slack is fine. Martin has requested a little album of him with his friends. So yes. Okay, so we'll get started with Melissa on the first key transparency talk.
All right. Oh, goodness, that's bad. So I thought I'd give sort of an overview of key transparency, since it's a little bit different from some of the other things we've talked about, and also a little bit maybe more in the beginning stages and little earlier stages and more research oriented than some other things. So I'm going to give this overview of what it is. I'll talk about sort of what the status is in terms of deployments and also some of the areas that research is still pretty active. Okay, so I'm going to give my pitch for key transparency. So end-to-end encryption, everybody I'm sure has seen this. You encrypt on your device, you send it over the potentially untrusted service provider, it gets delivered to your contact's device, they decrypt locally, nobody can see anything. Even if the service provider is compromised, your traffic is intercepted, your data is secure. So that's all great. Except when we draw this lovely picture, we have keys, but it's not clear how they get there. And so, for example, Bob wants to talk to Alice. How does Bob get Alice's public key? And in reality, the way that Bob gets Alice's public key is Bob asks the service provider, OK, what's Alice's public key? The service provider helpfully provides the public key that Alice uploaded when she first installed the app on her device. So that's great, but we can all see there's a problem with that, which is that the service provider, who's the untrusted entity in the system, can pick their own public key and pretend that it's Alice's, and then Bob will happily encrypt, the service provider decrypts, re-encrypts under Alice's real public key and sends it along, and nobody just, if you don't add anything to this system, Bob and Alice will never notice that this is happening. But now you have 0 end-to-end encryption guarantees. The service provider is reading all your mail. So that's not great. So obviously we need to do something here to verify that you're getting the right public keys for your contacts. So if we look at sort of traditional research in academia on end-to-end encryption, it just assumes, oh, we have this trusted public key distribution, and we'll put that off to the side and assume that's solved, and then we'll focus on how to do the actual end-to-end encryption key ratcheting and things like that. And in terms of industry, the sort of traditional approach is just been to say, well, we'll make somewhere in the app, we'll make it so that you can find a hash of your public key, and you can somehow contact your friend on another channel and read this hash aloud, or maybe if you happen to be physically next to them, you can scan a QR code on their device. Which is all great, but if we are talking to somebody over a chat platform or whatever, that's how we know how to contact them. It's not necessarily even true that we have an out-of-band channel, and we probably don't want to contact them on the out-of-band channel, because that's why we're using this particular chat platform, and we're probably not in the same place. So QR codes are not super useful. Sometimes they work. If you're really diligent, they work, but a lot of people, I mean, the overwhelming majority of people, I think we've already discussed, don't do these kind of things. The other fun thing is that every time you reinstall the app or you get a new device, then these keys change and you have to redo this process with all of your contacts. Yeah, so this is some, I think this was from Keybase. They estimated that if Alice has dozens of contacts, some of her contacts will, at least one of her contacts will reset their key like every few days. So this is, if you were to be really diligent about this, you'd have to be doing a lot of QR code scanning or a lot of out-of-band calls to check fingerprints. And I'll just say that most of this is for messaging, but for calls or meetings, there's sort of something similar where users instead read the security code aloud in the call, which adds its own level of sort of interest, because now you're reading the security code over the in-band channel instead of the out-of-band channel. But it's just as inconvenient. And in fact, there you have to do it in the call, every time you make a call, and every time a new user joins the call. So that's even less likely to actually happen. So we have this lovely thing, which is end-to-end encryption, but it sort of has this key piece that's not usable at all. And as a result, we don't get the guarantees that we want from end-to-end encryption. So that's the pitch for key transparency, which was first proposed in a work called Connix by Millar et al. In 2015. And the idea there was that we're going to use transparency to solve the problem. That's probably a big surprise here. So we'll have the service provider commit to the directory. So the directory mapping, say, usernames or some kind of user identifiers to public keys. And then when Bob wants to contact Alice, Bob asks the directory for Alice's key, but it comes along with a proof that this is the key that's actually in this committed directory. And then Alice's device will, in the background, regularly monitor the directory to say, OK, what is my key now? What is my key now? What is my key now? And make sure that it always is actually the key that the device itself generated. Yeah, right. So this is really nice from a usability point of view, because in sort of the normal case, absolutely nothing happens. And in the only case where the user sees anything at all is when their key does change, a new device gets added, and then the user should get a notification that says, there's a new device added to your account. Was this you? And the nice thing is there the notification is going to the user, who's the one who actually knows whether they added a new device. So it's sort of a more natural thing than your contact changed their key. I don't know if they added a new device or not. So from the usability point of view, it's a lot better, at least. Doesn't make any unreasonable assumptions on users, and we can construct it from fairly simple building blocks. So hash functions and then something called a verifiable random function, which is relatively simple public key primitive. So I'll talk about this a little bit more later, but just to sort of preview, this is actually started to be deployed. So WhatsApp, Apple, and ProtonMail all have working key transparency systems. And this is my picture of how it works. So a service provider posts commitments. Bob looks up Alice's key and gets a proof, and checks that with respect to the posted commitment. And the service provider regularly gives Alice proofs that her key is correct. And it's, of course, important that we have some way of publishing these commitments and making sure that everybody's seeing the same commitment. Otherwise, all these guarantees fall apart. OK, so I just thought I'd include a very quick sort of slide on why this is maybe different from say, CT. So I guess one of the, I think, biggest differences here is the data structure needs to be a little bit different. So in CT, you really just, what you're mostly concerned about is inclusion, is this thing in the log. In key transparency, I need to know, is this the one public key that's listed for this user, or a list of public keys, or whatever it is? And that's important because if Bob looks up Alice's public key and gets back, one listing that's, for Alice, and a public key, and uses that, and then Alice is later checking to see if her public key is correct. If she's looking at it, if there's sort of two entries labeled Alice, then she can be shown one that actually has a real public key, and Bob can be shown one that has the fake public key. So we really need this sort of unique place to look up the public keys for Alice. And I guess the other interesting thing is that you have more privacy concerns in here. So you don't want to publish usernames. You ideally don't even want to publish information about when was the user's account generated, when did they change their keys, things like that. Which also means that I can't just like scan the whole log and see, whether there are multiple entries for the same user, because we want to hide the usernames in the log. So we need a little bit more fancy data structures to handle this privacy and lookup. And I guess the other thing is that it's a little bit of a different ecosystem in the sense that there's usually, it's at least so far, it's the single entity, the service provider that's providing the messaging service, or the end-to-end encryption calls, messaging, whatever service, that's writing to the logs and hosting the log. So we don't have to worry about, it's in some ways simpler because we don't have to worry about coordinating between many different entities that are publishing and many different logs that are storing. We really can just have one log and one entity writing to it, and then we just need to make sure that everybody in the system is seeing the same commitment. Okay. Right. So in terms of, I thought I'd give a very brief overview of what the data structure looks like, because as I said, it is a little bit different. It's still a Merkle tree, so not that different, but a bit. So what we need is a way of committing to basically a dictionary. So you can think of like a label value store that maps usernames to public keys. And we need that there's a unique entry per username. Excuse me. And we need to be able to give a proof that the public key returned is correct, obviously. So the construction that most of the works are based on is what's called a sparse Merkle tree construction. It was first used in sort of academically in Connix and in industry in this company called Keybase, which I think is now swallowed up by Zoom, but was doing something a bit like this, but with less privacy. And yeah, it's still the basic thing underlying, I think, all of the deployments at the moment. So the idea is sort of, say I have 3 users, Alice, Bob, and Mallory. And they each have a public key. Really, it's a set of public keys. A list of devices can be a lot more information, but say for the picture, just a public key. I'm going to hash each of those. That gives me a leaf position in some really like exponentially large public Merkle tree. And so you can see I put those 3 nodes there. And then you can think of it as I'm just going to collapse all the nodes. Any node that doesn't have 2 children, I'm just going to remove it. So I'm just going to collapse all those. And there's a little more bookkeeping you have to do to make sure that you're not losing information when you do that. But so now I have this cute little tree. And then at the leaves where, say that second leaf there corresponds to where Bob hashes to. Then I'm also going to put a commitment to Bob's public key, so like a randomized hash of Bob's public key, and then I'm going to hash that together with Bob's this leaf position, and I'm going to put that in that leaf, and then I'm just going to build my Merkle tree from that. So hash on up. And again, I'm hiding a little bit because you have to do a little bit more bookkeeping in the hashes to keep track of the nodes that you deleted. So the nice thing here is we can, just like in any other Merkle tree, I can give you a nice inclusion proof for Bob. And it's just logarithmic, so logarithmic in the number of entries and the number of users in your system. And let's see. Yeah, so your trees are relatively short. You have nice short proofs. And the thing is, because we're sort of choosing the leaf position based on Bob's username, you can say there's like a unique place in the tree that would correspond to Bob. So if there's a node there at all, then that's Bob's public key. And you know that when Bob looks it up, when Alice looks it up, everybody's going to hash the string Bob, the username Bob, to the same leaf position, and so everybody's going to be looking at exactly the same part in the tree. Right. Okay, so that's sort of the basic thing that underlies all the deployments so far, and it's nice because it's no fancy crypto. It's just, again, it's just a different kind of Merkle tree. Downsides of what I presented so far, one is sort of client monitoring. So if every epoch there's a new commitment, now Alice's client is going to have to check every epoch to see if her key is correct. And if she goes offline, then when she comes back online, she turns the device off. When she comes back online, she's going to have to check all the epochs that she missed and say, oh, was my key correct? This one, was my key correct? This epoch, was my key correct? This epoch. And for this reason, I think the original Connix paper proposed that epochs were like a day long. It has the downside that if you install the app or something like that, you don't get any, you can't use the key transparency for whatever, a day until afterwards. Boop, boop, boop. Right. The other downside in this, as I presented it, is privacy. So if we're sort of including a leaf in the tree for that just corresponds to the hash of the username, then you could sort of do a brute force search for all the usernames and see whether there's a leaf in each of those positions in the tree. So that would like leak all the usernames in your directory, which maybe those are phone numbers, maybe those are email aliases, something like that. So you don't want to do that. It also a little bit more subtly, but it can reveal information about when the keys are updated. So if you reveal the structure of the tree, or even if you can see enough paths that are near a particular node, then you can actually see when that node changes, right? Because when that node changes, it changes all the hashes up the tree. So it also reveals some information about when users are changing their keys, which we may not want to leak. So I'll just talk sort of briefly about how these are addressed. So the first one, this sort of requiring the user to check that their key is correct every epoch. Because note, if the key isn't correct for just one epoch, then that might be when Bob looked up Alice's key and the server snuck in knows Alice is on vacation or asleep or something and snuck in a bad key then and managed to intercept that conversation. So it's really important that we can check that all of the keys are always correct. Yes. So right. That's what I already said. So the idea in terms of reducing the monitoring cost is just instead of having every commitment be sort of a fresh independent commitment to the directory, we'll have these commitments sort of roll up and include all the history that's happened before. So basically the user does one query and they can see everything all the operations that have happened to their account since they first registered with the system. And there's a little caveat there, which is that you don't want your storage to grow infinitely. So we do eventually, most of the systems eventually delete really old stuff. But at least you can see all the operations that happened over the last couple months or something like that. Right. So the idea then is also the server, instead of like forming a whole new commitment to a directory, which is expensive, they just sort of add the new information, any new updates. And then I guess the key part is how do you know that the server is doing that they're actually like just adding to the old tree and not forming a new tree or changing some nodes. And there we need something extra, which is that we're going to have some kind of proof that says this tree is only adding to the previous tree. And I'll just note that that's a little bit more subtle than proofs for, like CT being append only, because you're not just adding to the right, you're adding like all throughout this tree. And I guess, there's sort of a little asterisk, which is who checks these proofs. And there's sort of different approaches, but generally the assumption is that I'll talk about it later, but often the assumption is that there's a third-party auditor that's helping to check these proofs. Okay, so the nice thing about this approach, though, now is that the cost for a new epoch is really small. Like the user doesn't have to do much extra work. If they haven't made any changes during that epoch, then they just have to do maybe one extra query that says, has anything changed? No? Okay. And the server only has to do work that corresponds to how many new updates happened in that epoch. So you can make the epochs very short, so 30 seconds or a minute or something like that. So now we're actually you can register a key, install the app and use it immediately, basically. Okay. So the other thing I was going to talk about was privacy. not going to say a whole lot, but yeah, so the two concerns are basically, one, you may leak the usernames or user IDs, which could be phone numbers, could be email addresses, even just like user handles. You don't want to just make those publicly available. And the other is that you're revealing now this timing information potentially about when users change their keys. And why do users change their keys? Maybe because they think they're hacked, maybe because they got their new device, maybe because they're traveling out of the country. So it can be things that you don't want to reveal. So I'll just say, ideally, we would have a key transparency system where if I query on Alice's key, that tells me nothing about any of the other users. So I don't get to learn anything about their usernames. I don't get to learn anything about when they update their keys. The only thing I get to know is maybe like total number of users in the system. And even that you can pad up to some maximum. Right. And so I'll just say there's sort of these two types of privacy concerns. So some of the systems try to address both, and some just focus on the first one. Like they say, well, we're going to hide the usernames, but we're not going to be too concerned about this timing leakage of revealing when sort of an unidentified user is changing their key or registering a new device or something. I guess the other thing is if you query for a user once, then you know sort of which user this is, and so then it's not really an unidentified user anymore. You can actually say, okay, that user that I queried once who blocked me now, I can now see every time they get a new device. So there is some... The second box can be, I think, a little bit more sensitive than one might think. Okay. Right, so I think that's sort of the basic thing that's common to, I think, all of the systems that are out there so far. I thought I'd talk about a couple of the areas that where there's, I think, more open questions in terms of which option to pick. So I'll talk about some of the challenges, the different options different systems are taking, and some of the research that's happening. So the first one is preventing forking. So as we said, we have these, the service provider posts a directory, commitment to the directory, but it's really important that everybody sees the same commitment, because if you have different commitments, then the one that Alice is monitoring may not be the same one that Bob is looking up Alice's key in. Right. So there's a couple different options. So sort of research-wise, I think sometimes it's written as, we'll just have some trusted third-party bulletin board where we'll all post all our commitments. I haven't actually seen anybody use that. Another option would be to post on the blockchain. That has its own cost issues, plus just integrating with the blockchain integrating your app with the blockchain is not something you want to do if you don't have to. There's been some interesting work on building building this kind of bulletin board-y functionality based on trusted hardware. And then I guess the one that seems to be most common at the moment is this idea of having like a third-party signer. Basically, you have a trusted third party who commits to only signing one commitment per epoch. So then the third party, the service provider sends them their commitment every epoch, they sign it, and then give it back to the service provider, and then the service provider can present it to the user and say, okay, well, here I've got a signature from this party. They promised they'd only sign one thing per epoch, so this is the one commitment for this epoch. I think it's an interesting so that's sort of, I guess, the status. I think there's an interesting question on whether we can remove these various trusted parties, at least somewhat. So I guess one approach is just say, okay, well, we'll gossip this commitment among, the different users, but it's assuming that the users sort of have an external social gossip network that's outside of this social network that we're implementing is not ideal. And also then you get back to this inconvenience of now we have to read things out of band over some other channel, or at least connect to some other channel anyway. I guess another, I think, interesting idea is to use in-band gossip. So basically to have the users send the commitments on the same channel that they're communicating on. So on this end-to-end encrypted channel that we're implementing, it's a little bit circular, right? Because now you're securing the channel using this gossip, which is happening over the channel and assuming secure connections. So I think it has to be done very carefully. It was first suggested in this paper in 2022. Their guarantees are slightly strange and very weak, but it's an interesting idea. I think Apple is doing something like this, but I don't think they do any analysis. And there is a failure mode, right? Which is that the service provider just says, "Oh, everybody in the world has changed their keys." They tell everybody that, and now they can man in the middle of every channel. And then if your client doesn't like check for that or account for that in some way, then you can sort of trivially break at least this check. So we probably need at least some out of band something or something extra. So we have been, Esha, Gosha, and I have been looking a little bit at this problem, and we have like a little toy protocol that sort of says at least we can reduce the number of out-of-band messages we have to send to sort of a minimum, but it's that the protocol we have is completely fictional. It's completely theoretical, but I think maybe you could do a lot better. And there's also an interesting work, which I think Elena is going to talk about, which looks at using sort of small committees of users. And I think it does add a little bit of extra assumption that has an external identity provider, but it's also a different approach, which I think is nice. Yes, okay. So that's sort of the one big problem, which is how to get the commitments out there. The other problem is, as I said, if we want to do this thing where the tree includes all the past history, we have to have somebody actually check that the tree is, that the service provider is accurately sort of adding to the tree and not just completely replacing nodes, because they're not deleting any history. Right, so the cool thing is that we can make it so these proofs, despite the fact that there's a lot of private information in the tree, we can make it so that the proofs don't actually need to reveal private information, which is cool. So we don't have to trust these auditors for privacy. We're just trusting them to make sure that the tree sort of doesn't ever delete information. So in theory, you could have just publish this somewhere and users could download all of the proofs and verify them themselves. In reality, the proofs are really big because, they include information about all the users in the system. And so far, this is not really practical for individual users. The other option is to have, sort of third parties who are usually commissioned to do this auditing. In terms of research work, there's been some work on trying to reduce the cost of these audits to make it so that you could ideally run them on user devices, or at least to make it so that there's less work for this third-party auditor to do. Particularly using snarks. And actually this last iron dict is on ePrint, but it's I think it's really nice. They use a different type of commitment, so it's not a Merkle tree, but so it's like a pairing-based commitment. So downside, you need pairings, but the upside is they actually get really good efficiency, at least according to the paper. So that I think some promising work there. Another sort of interesting approach is these approach that was sort of proposed in Versa, where you get a slightly weaker consistency guarantee, but basically instead of having somebody check that the whole tree is growing correctly, you sort of have each user do slightly more checks, and the guarantee you get is just that if Alice does logarithmically many times as many checks, and Bob does similarly, they'll intersect somewhere, and so they will catch an inconsistency. So basically, then you don't need to do these kind of global checks anymore. You just need everybody to do somewhat more work. The downside is that even if Alice and Bob do this extra work, it doesn't help anybody else. So you're sort of paying the cost in some ways extra. But at least it's an interesting approach. It's a different approach. So we've been doing some look at how to integrate that into like the seamless, which is or optics, which is the system where it keeps the history, I guess. And I think that could be optimized a lot. Okay, the last thing I was going to mention is whether we can get a bit stronger security. So in these systems, at least as I described it so far, like the service provider is generally the one who controls the directory. So they can totally replace a user's key with a different public key. They get to pick what to give to Bob. It's just that the user then, when their device monitors, they'll see, oh, my key changed, something happened. So this, user detects it, but they can't prevent it. So can we do better? And the answer is sort of. So if you have many devices, you can actually, and this is what Keybase was doing, and we had a follow-up work with them where we work in some more of the privacy. But basically the idea is that if you have many devices, then as long as you have access to one of your other devices, when you're adding a new device, you can sign that new operation. And so then you get this sort of chain of signatures. And as long as you have a chain of signatures back to something that's been in the directory, you don't have to notify everybody. Sorry, you don't have to treat it as anything new. So you can sort of suppress those notifications. You don't have to notify the user on all their devices, oh, you added a new device, if they've signed it, because you know that's sort of OK. And so then the nice thing is then, when the user does lose all their devices, because for usability, you do have to support that, then you have like a special, very unusual reset operation that comes with lots of big red flags on the UI. So you can sort of make that the messaging much stronger, and it's less likely that the users will just click through it. So you can't completely omit it, but you can do better, I guess. The service provider can still replace your key, but at least it'll be more noticeable, I guess. Right. So I thought I'd briefly talk about sort of what's deployed right now. So it's cool. I think there are 3 different systems that are using key transparency in the world. The first is WhatsApp, based on I think the paper is called Parakeet, or the system is called Parakeet. And so that one is using the sort of fully private approach, where basically every time you add, the user updates their key, you sort of put it in a completely fresh place in the tree. We do it carefully so that it's always the same place so you can find it. And so you get like full privacy, so that you don't even leak the user's sort of pattern of key updates. They're using Cloudflare as the auditor to check these audit proofs, and also Cloudflare as this third-party signer to prevent the forking, to make sure everybody's seeing the same commitment. Then iMessage has a system. I think that they do the approach where they're focused on hiding the username, but not so much hiding this sort of pattern of when keys get updated. I don't know exactly what they do, but they do say that there's some, the client does some auditing, but some of it you would also need a third-party auditor to detect. And they do this interesting thing of gossiping the commitments in band. And then the last one is Proton Mail. They also only focus on hiding the usernames, not hiding the sort of update patterns. And they, I believe, post their commitments in the CT log, which is sort of an interesting approach. And I think they also have need a third-party auditor. I'm not sure what they're doing for that. Okie dokie. So I'll just briefly, maybe very briefly mention. So there's, I think, a bunch of other questions that you have to answer if you're actually going to deploy this, and each of the systems does it a little bit differently. But so I mean, in terms of security guarantees, if a user never comes back on to monitor their account, then now they stop using the system. Now the service provider, if they can figure that out, could impersonate them forever after. I guess another question is what is the username that you want to use for your system? And particularly, it's tricky if you have phone numbers and they can be transferred to other users, or you have something that you want to stop using a username or something like that. How do you manage that? There's also some interesting things about what's the best way to implement the trees? How should you represent it in memory? What should you store in memory in a database? Actual implementation questions. As I said, you need to be able to delete old data, and different systems take different approaches in terms of how do you figure out what's old enough to delete. And I guess sort of how can we optimize this monitoring operation? Because ideally, as often as possible, Alice's phone is going to be pinging to say, has my key changed? Has my key changed? Has my key changed? So we want to make that as lightweight as possible. So I'll just mention we have some initial ideas on these different things in this paper from last year. But I think there's a lot more interesting to do on that. Another thing to mention is in terms of implementation, there's one. We meaning Kim and Radimus from my team at Microsoft Research have been building out a lot of this. And some things we learned. One is database operations are a bottleneck, particularly when you're doing the update because of the way the data structure works. So that we were surprised that it wasn't the crypto. It wasn't even the public key part of the crypto. It was just writing to the database that was constraining how fast we could do, how short we could make the the epochs and how many updates we could do. Other thing is audit proofs can be large, and that represents a challenge. And I guess the last thing that was somewhat surprising is that storing long-term user keys was surprisingly a pain. Ideally, we would store these in hardware on the user device so that you don't have malware that can like export your keys. That surprisingly wasn't that common a pattern. It does occur, recently in some of these passkey systems, but each platform does it differently, and so like trying to implement this was a pain. So Kim and Rodimus implemented this nice library called MPSS, which is meant to be a multi-platform secret storage library that works that stores keys in hardware according to each platform's different way of supporting things in hardware. Supports Windows, Mac OS, iOS, Android. They're planning to add support for UV keys and Linux as well. And so that's open source and available. So hopefully that will be useful to some of you if you ever need to store keys in hardware. Oh yeah, and I guess the last thing is it includes an open SSL provider, so it's easy to integrate with your existing crypto. I guess I mentioned just a couple other questions that I think are interesting and haven't been explored that much in this space. So one is how to do the UI or explain key transparency to users. I think each system takes a slightly different approach, but sort of explaining the guarantees and making them feel like that it's secure, but also explaining the failure modes. And because if the user doesn't know what to do when they get a message saying your key has changed, or that they saw two different bad proofs or something like that, then you're not getting the security you want from the system. So somehow making sure that you're correctly training the users, but also not writing scary messages like this means a attacker has broken the entire system and all of your mail is compromised or something like that. So I think there's some subtlety in how to do that properly. I think a whole missing piece in most of this research is it assumes that the client code that's checking these proofs is trusted. And I mean, you sort of need to trust your end-to-end encryption client somewhat anyway, because they're doing the encryption if they want to. If your client is completely busted, it can be sending the plain text somewhere else. But is there any way we can make that a bit better? Make these at least some portions of these applications audited, or adding some code transparency, some verification, something like that. This, I think, has come up in other contexts, but how to respond if there's a bug in the server code. I think this is a good application for for code verification, because this is somewhere we really don't want bugs. And I guess a sort of a subtle issue here is that the user, if the user sees an update on their account that they didn't perform, it could be that the server is trying to man in the middle of their account, but it could also be that an attacker has stolen their password and logged on and changed their account, and the service provider is completely honest. And there's no way sort of to tell the difference. So I think it'd be nice if there was some way to tell the difference, or at least to communicate this sort of ambiguity to the user in a meaningful way. So I'll stop there. Happy to chat lots more about key transparency with anyone who's interested. Thanks.
Amazing. Do we have questions for Melissa? I know it's the first talk of the morning, but you can do it. Like it was just too clear. No,
Hi. So you listed a few cases where this is used. WhatsApp was one of them.
Yeah.
Which of those are open source?
I don't know. I think there is some code for WhatsApp, but I'm not sure if it's actually the code they're using or if it's the research code. Maybe somebody else knows. Yes. Thanks.
So I think Signal is trying to move towards KT, and everything should be open source there.
We have an open source client as well, we meaning Proton. but the server is not so far. But,
Awesome. Thanks.
Yeah, thank you. Thank you for the talk. Maybe I missed something. There is a lot of efforts with key transparency to remove trust from the service provider. But at the end of the day, it is the service provider who builds the UI that will display the errors of the key transparency. So is there a way around it or no?
Yeah, I think that's a good. That would be sort of a bit this second bullet of like, how does the user trust the client code? Because the entire client is written by generally written by the service provider. So you could have a service provider that will interoperate with, independently written clients. That would be nice. You could have the code at least audited, maybe some kind of like combination of code transparency and third-party auditing or something like that. But yeah, I feel like that is one of the biggest missing pieces at the moment. Because as I said, you can do as much fancy key transparency as you want, but if your client is just sending the plain text somewhere else, then it doesn't do you any good. Yeah. But that's true for end-to-end encryption in general, right?
Any more? Well, in that case, let's give Melissa another round of applause for that wonderful talk. And next, we're going to invite Brendan to the stage to also talk to us about key transparency. That is what this set of talks is on, so it makes sense.
It does make sense. Okay, very cool. So I'm going to talk a little bit about key transparency as well, mostly the security model. My name is Brendan, and I am the author of the key transparency standard that's being developed in the IETF. So for background, the kind of key transparency model works a little bit like this. We have some user, Bob. Bob wants to talk to some other user, Alice, on some messaging service. And so he goes to that messaging service and he says, hey, what do you know about Alice? And the service can come back with a lot of things. It can come back with Alice's user ID, which he might need to address messages to Alice. He can also come back with her public key for end-to-end encryption or her profile picture or all kinds of other settings and configuration and stuff. And so that's what Bob needs, but that's not the whole story. Alice also needs to be involved here as well. And her job is really to come online occasionally and basically just check that she agrees with what this messaging service is telling people about her. So she comes online and she says, hey, what are you telling people about me? And she gets all that same stuff back. And she can go through all of it and say, okay, yeah, that is actually my user ID. That is my public key. That's the picture of me. That's all of my other configuration I like as well. And the core security property of the system comes from, knowing for sure that what Alice is told here is the same as what Bob was told in the past. And so then the next question is, how do we actually build a system like this, or how does Alice really know what people are being told about her? Well, obviously, Alice puts all of her information into some kind of transparency log. The issue there is just that most transparency logs are just going to be logs of everything that's ever been said about anyone. So for Alice to find the things that are only about her, she'd have to download the whole thing and filter out the whole thing. And if this is a pretty large log, that can be really overwhelming for her. So what we need is to organize the log somehow. And that's how we get back to this filing cabinet analogy that I really love. So if the log is organized, then Alice can go straight to wherever the information about her is stored, and she can forget about the rest of the log and just look there. That's quite nice, but this only works if we know for sure that these filing cabinets are organized the way that we say they're organized and that nothing is missing or in the wrong place or whatever. And so to actually assure ourselves of that, there are a couple of different approaches that are used. One is basically just to say that, okay, all the filing cabinets are public. Anyone can come and look through the whole thing and make sure that it's sorted how we say it is. In practice, the main issue there is really the bandwidth cost. So we said this is too much data for Alice to download, but if it's like 100 gigabytes, someone will probably come and try to download it, but 100 gigabytes is a lot of data, and if we're serving that again and again, that can start to cost a pretty significant amount of money for the service provider. And then a secondary problem is also really the security of this, because we're saying the security of our system relies on someone coming and doing this work, but we're not actually making sure that anyone ever comes and actually does it. So in a big ecosystem like CT, it really is reasonable that someone will care enough to come and do this. But if I just have an app that's for like cat lovers in the Bay Area to talk to each other, it's a little bit less credible that someone is going to consistently care enough to go and do that work. So based on that, a second option is that we can appoint somebody and have some trusted third party to actually come and do this work. That's quite nice and is definitely secure, but it causes a lot of problems that I kind of all put under the umbrella of operational burden. So, I mean, first of all, you have to find this person, and that's not very easy. You also have to worry about, like, what if they have an outage, or what if they just decide to quit one day? Like, you've told your users to expect some assurance from this person that you're operating correctly. So if they just disappear one day, that looks bad for you. And also, if you ever want to change the protocol you're using, that you have to, like, get them on board with it as well and get them to deploy changes, and that's annoying. And really, at the end of the day, the biggest question is, why would your users trust this person in the first place? Because you have some kind of business relationship with them, you're maybe paying them, so how credible is that arrangement really, that they're going to like hold you accountable? So kind of in the complete opposite direction, and what we mostly focus on in the standard in the IETF is that we mostly just reduce this work. So rather than having someone check the whole filing cabinet, we just have users check that the specific information they care about is actually stored correctly. So what that looks like is really in step one, Bob comes up and he looks up something about Alice, and he makes sure that the information he's told also exists in Alice's little file folder where she will know to look for it. And then Bob can also come back later and make sure that same information that he saw in the past is still there. And so the intention of that is that if the messaging service has something wrong about Alice, then Alice will come online in step 1.5, and she will see that something bad was said about her, and she can be mad about that. Or if the service provider tries to basically cover up the fact that it did something bad, then when Bob comes back in step 2, he will see that what he saw before has been removed from the log in the meantime, and then he can be upset about that instead. So either way, one of them is going to be mad if the transparency log misbehaves in some way. And a nice optimization that we can do about this is if Bob comes and he looks up something about Alice and he sees that it's relatively old, then he can kind of reasonably assume that Alice already has had the opportunity to see that, and so he doesn't have to worry about coming back later. And the really huge benefit of this approach is that even though Bob has to do some more work sometimes, the end result is that the protocol is totally functional and secure and complete out of the box. So as a service provider, all I have to do is deploy my server. I put this code in my clients, and that's it. I'm done. I have a complete system that now I can deploy and tell my users I have key transparency. And so that's really cool and a huge benefit. So the very high level way to think about that benefit is that, or that approach there, is that what we've done is we've made Alice and Bob essentially their own trusted third parties, and those are actually the best people to be the trusted third parties in the system because they're the ones that are most incentivized to actually hold the service provider accountable and to care if something goes wrong. And the reason that model works so well for KT is because, first of all, users love opening their messaging apps, so users are pretty consistently online, and users also tend to have pretty robust local state since they care a lot about not losing their messages. So putting those two things together, it means that if I give one of these users some additional homework, like, hey, come back later and make another request, there's a pretty good chance that they will actually do it. And also, most people don't actually talk to that many people, so if there is additional work to do, it's not actually that much work. So yeah, that's all I've got. Please read the IETF drafts, give feedback. Also, if you want to read my code, that would also be very welcome. That's all I got.
Thank you, Brandon. Do we have any questions for Brandon? Yes, we do.
Thanks. Nice talk. So you talked a little bit about like reducing the work required for an independent auditor, but could you talk a little bit about like split view consistency in the sort of users audit their own messages context? Because it seems like you could serve different things to Alice and Bob, and each of them would see something locally consistent, but not consistent with each other.
Right, that's a good point. So in a lot of KT systems, one of the goals of like a third-party trusted auditor is to make sure that you have protection against split view attacks. And so if users are their own auditors, then you don't really have that same thing. So what we recommend pretty strongly in the IETF draft is either peer-to-peer gossip or this idea of an anonymous channel. So if you talk to the log and request the log state over an anonymous channel, then it's very hard to consistently serve one user a split view because you don't know who's talking to you over that anonymous channel. And actually, that is a pretty good approach with like a mobile device context, because mobile devices are kind of their own anonymous channel where they're always moving around and connecting to different networks. And so if the request is not inherently able to be identified back to a single user, then that would seem to be pretty effective.
Anyone else? Okay, well, let's thank Brendan again. And for our final talk of the summit before we have a break and then a fun quiz, we have Elena.
Yeah, thank you. Wow, last talk before the break in the morning. I'll try to entertain you with a little new idea. I'm new in all of this area of transparency and key transparency. I started working on it roughly a year ago. I found it super exciting. So you will probably see me sticking around for a few more years. I also have a PhD student on this topic, so at least 4 years are going to go in this direction. What else? I'm an assistant professor at Chalmers University here in Gothenburg. So if you like this wonderful environment, you can come back and contact me anytime with question about this topic and other things in cryptography. So I want to tell you something about transparency. Like, how do we introduce transparency? How do we ensure consistency of the way that people the tree hash they received or the view of the keys in my KT log? And I want to pickle an idea that is building on what has been suggested during the previous talks. So we have seen like auditors out there, we have seen like clients trying to audit each other, and I am just suggesting a twist to this through anonymous committees. So just to put a little bit of a framework, bear with me, I am a academic, so I like to have like good names, good frameworks, good systems. So this is clearly a log. I'm not going to say what the log is, but actually it's nice to have a proper definition of a log, and a transparency log is not exactly a log, it's a log with additional properties. But at a high level, we're going to have submitters, so some people that are putting things in the log. We're going to have advocates, so somebody who is checking the quality of the log. And we talk about append only a lot, but I think in general I could have a growth policy, an evolution policy, and I want that these advocates will check that the log is evolving as it's supposed to. For instance, that the keys are updated as supposed to, or that is append only. And if they think that this is indeed happening, then they can maybe sign. And then consumers that are consuming the log can download and see, okay, I collect enough signatures, that's good enough, or there are signatures of the people that I want to be there, so I'm happy. And I want to clarify there are two type of consumers of the log. There are the direct consumers that actually talk to the log and download from the log, I don't know, the latest hash tree and all the signatures or the whole tree and whatnot. But everything is publicly verifiable. We don't have any designated verifier. We don't have any secrets. So they can broadcast what they got to a lot of indirect consumers that don't need to talk to the log but can benefit of all the transparency guarantees of the log. Okay, so let's see a little bit of an example with the SIGSAM by Glasklar and the witness co-signing paradigm. So what happens over there is like advocates are basically providing their digital signatures, and consumers this digital signature will go to the log, and direct consumers download this from the log, and then they will check. Do all the signature verify for the same view of the log? Then it means that I have 4 advocates saying, yes, we agree that this is the view of the log, and the probability that the log has been corrupting all of these keys is low, so I can be sure that there is a consistent view. Everybody who is downloading the current view of the log will see the same things as I've seen. But there are cases where maybe, does this actually point to something? No. I don't get a witness signature. What do I do there? The witness is offline. Or maybe a signature doesn't verify. What should I do in that case? How can I make sure that there is no split view happening? And on top of this, there are still two issues, I think, with this witness co-signing paradigm. One is that witnesses are fixed and known. So I know that there are 12 witnesses out there. If I am a state-level adversary, I can just target to corrupt precisely these 12. Yes, it's expensive, but it's a finite amount. And once I target them for corruption, I can make them sign more than 1 3 head, which is what they were supposed to do if they were honest. But now if I sign 2 3 heads, then I can convince Alice that her key has not changed, and Bob that Alice's key is different. And second, to prevent split view attack, one needs to verify actually kind of many signatures, because you want to make sure that if Alice and Bob have the same view, this is ensured as long as they check one signature of one honest party. The same honest party, not different ones. So there needs to be a sort of overlap that has been mentioned also by other people. And the formula we got so far is like basically you should check a quorum, many signatures, and they should be roughly half of all the existing signers out there. If every user does this, every consumer does it, then you're sure there is no split view attack. And it's more than half if you need to count for there being malicious parties or silent user advocates. So it's not as little as you think. Of course, you can check all the signatures in the worst case, and that works. But here it comes a bit my idea. So I have a log. If you think about key transparency, like I have a bunch of users, everybody's using the log for the communication messaging and storing the key in the key. So I will upload if I'm doing some updates of my keys. And then I don't want to have an external set of fixed users. Can I use the same user pool of the log to do the advocating, check that the log is actually not delivering split views? So the idea is like, yes, we can run a cryptographic lottery. And this is basically like having a coin, flipping it, and then seeing, am I being selected or not? This is a verifiable random function, has been mentioned before. If you don't know what it is, think of a signature, unique signature for a message. If your signature is small enough, you're in the committee. If not, you're not selected. There are a bunch of things I'm hiding under the carpet, like you need to be secure under malicious key generation and whatnot, but I think this is not for the audience. So I have a cryptographic mechanism to randomly select people. Now, these are going to be the advocates. These are going to be the people that will actually check the log is growing correctly. And if it's growing correctly, they will deliver their keys, their signatures. And these shouldn't be just standard signature. We probably need to have a key evolution so that in case I'm corrupted after I reveal my key has already evolved. So you can no longer use the previous key to sign a split view. And then everybody that is active should monitor. So it's just a new paradigm. And I think there are a few positive sides. So that we remove the trust from a small group of designated witness to all the logs, all the clients that are actually using the log. We avoid gossip, which we know doesn't scale well with the large population, like the billions of users in WhatsApp. And it does not require peer-to-peer out-of-band channels. So this is particularly relevant for KT, as it's already been mentioned in the previous talks. It works best with many clients. The more clients we have, the smaller the portion of the committee we need to have. But it requires to do more work and more signatures than witness co-signing checking. So this is still a work in progress. If you're interested, this is the ePrint paper. So happy to get feedback and questions now or in the break. Thank you.
Questions or feedback? Yes.
Hi, thank you for the talk. Correct me if I'm wrong. This looks like some kind of distributed consensus protocol, and as far as I know, it has been solved already several times. For example, by Tor directories, their approach is some designated witnesses, and despite all the state actors, Tor has been holding up pretty well. And on the other way, something with a cryptographic lottery that has like a stake, witnesses, and strangers trying to verify the consensus is something like the Ethereum blockchain, that has a proof of stake with a lottery. Have you looked into these models, or?
So I have not looked specifically into Tor, but Ethereum, yes. But there is a, how to say, big difference between blockchain kind of things and transparency kind of things. So consensus, you achieve it by having a resource that is hard to replicate. Make it be proof of work for Bitcoin, make it be your stake that you're putting in the proof of stake. Here we don't exactly have a resource that is hard to duplicate. You're just assigning. So it's, in a sense, it's way more efficient than anything you can create with blockchain-like things. And yes, there is also a Byzantine fault tolerance agreement. Like, there are a lot of ideas out there. I'm just trying to do something that is efficient and fits the overall working of the log. But thank you for the pointers.
Thank you for the talk. This may be a naive question that I missed. Is like, what's preventing the service provider from just choosing or creating the witness that just agrees with the corruption?
So the fact that you're using a verifiable random function, so like a cryptographic verifiable random function, it's a coin that tells if you are in the committee or not, cannot be biased.
So, so that is the code that runs on a client, is that correct?
Yes.
Okay, so assuming that that construct will have to be like open source for audit, not like the service provider can just not run that function.
Yeah, but then in the moment in which I am providing like my witness signature, I also need to provide a proof that I have been selected in the committee. And then people will see, okay, this is a public verifiable proof. It doesn't work. You were not there. So we have thought about that.
Thank you for the talk. I was wondering how you square the idea of, so some KT implementations have witnesses that have to do quite a lot of work because proofs get quite large, and these witnesses are stateful. They carry a copy of the tree, which is, again, quite large, and then apply updates very quickly as they stream in. How do you imagine clients, like somebody on their phone, doing something similar in a short period of time, depending on how frequent rounds are, and also in the face of people coming online and then going immediately offline, but being elected possibly for verification in that time?
Okay, so I split the question into two: how to do with like offline users, and then you can just model saying, okay, the probability of selecting a user is a binomial distribution, and I have a portion of people who are offline, so there is a way to handle with that. The other question, it's very relevant. I admit I am a mathematician, I'm an academic, so I just thought, okay, the log works, there is a way to check it efficiently, but I'm realizing that's not the case. But the twist I would do is, like, instead of necessarily having the users, I can just increase my pool of witnesses. So instead of having just 100 people, I can actually have like thousands of people. So you can have a small threshold to become a witness, just enough to make sure that not only malicious witness will sign up to this doing the job, but then you know as a witness that you will only act, I don't know, every 5 epochs to do the actual hard work.
Gotcha. Thank you.
Thanks for the talk. You mentioned that you need some barrier for, preventing just malicious witnesses for showing up, but this seems like it assumes either some sort of, like was sort of discussed before, like stake or identity or something to prevent, just fabricating, twice the number of malicious witnesses as there are like honest witnesses. Do you have like ideas how this would work in like a open messaging application? Yep.
Very good point. I think Melissa already mentioned that we kind of rely on there being an identity provider that says these are all different people. And in messaging, it's very easy. You all have different phone numbers.
Yeah, but those are not like publicly verifiable, right? I mean, like the only people in Signal who know that there are real phone numbers behind an arbitrary person are the operator and like possibly their contacts, right?
Yeah, but it's still already a check that is doable. Another way is like, okay, maybe this doesn't scale to KT for messaging per se, but it would work, for instance, in Sweden, where the amount of social security number is something you can trust from the state. So I don't need to know whose security number, social security number relates to whom, although that's fairly easy to know in Sweden, sadly. Like then you can check up where I live and the average of my salary just on a hitta.se with my name. I'm the only one with this name in Sweden. But okay, what I'm saying is like there are ways to get like a public list. I'm saying this is the amount of people. There is no more than this. All I need to know is the total number of users, and then I can make an assumption saying, okay, I want to tolerate a third bad parties, just 0.2 or not.
Yeah, thank you.
But it's not bulletproof. I agree. We need to rely on something, but that's the way we can do it more efficiently than blockchains. Otherwise, you need to have a resource that is hard to reproduce.
No, that was the question.
It is a very valid question, absolutely. Yep.
Can you tell us about how big the proof is that has to be shared about I have won the lottery?
That is literally just a signature. Basically a signature, so like a group element.
Okay, so it would roughly double the size of what we currently have.
So you have like one group element. It depends on which implementation of the verifiable random function, but like we have a proof of concept implementation done by a master student, so it might explode in your hands. But so like the cryptographic lottery is one group element, and the key evolving signature, that's basically the pre-image of a hash. And a little bit more because you are evolving your key, so you need to kind of give, okay, now the next key that I'm going to use is this one, and the previous key is invalid because I use it once.
Okay, and also the association of the lottery happens like per log checkpoint. Roughly.
Per epoch, yeah. Log checkpoint.
And associating those is just clear enough?
Yeah, so like you can use like the tree hash as an input to your random thing.
Yeah.
And then it's like if you think that the log can actually cheat with that, you can also try to get an external source of randomness, a beacon, and say, okay, these two things at this time, I cannot bias it. And that's why we are sure that you cannot skew too much on selecting only the bad guys that are within my population.
Thank you.
Thank you.
Okay, I think we will leave it there because we have to have food time again. So we will have a break now and then come back for the quiz with the exciting Teletus hardware prizes. I think come back, I'll come and nag everyone when it's time to come back, but 11-ish, 11:05, and we'll get started on the quiz. See you then. One second. Okay, quiz time. Please take your seats for the fun and the games. I just ran to the other room, I don't know if you can tell, to get Martin's lanyard. He's now an official attendee, as you can see, and he's going to be helping us with the prizes. Well, he's going to be keeping an eye on the prizes. I'm not sure how much handing out of the prizes he will be able to do. A reminder for those of you who have really short memories or who maybe weren't here for the intro this morning. The quiz prizes that we have today, we have 5 prizes. So we have prizes for the top 5 participants. And all 5 of them, of these wonderful packages, contain some traditional Swedish treats, not edibles, oh dear, some traditional Swedish like sweet treats. And then the top 3 also have some Tilitis hardware. So a big thank you to Tilitis for providing these prizes. All of the top 3 get a Tiki. And then the first place also gets a Tiki Unlocked and a Tiki programmer board. So that's very exciting. Ooh. So yes, I mean, you're already on it. This is motivation to sign up and get involved with the quiz. Before I do start, we'll give people a little bit more time to get that done. I want to say a huge thank you to Edonna and Rasmus and Martin, although not Cardboard Martin online, who have all been amazing in helping curate this quiz. Throughout all of the talks, they've been sitting, noting down potential quiz questions, and then last night we had quite an entertaining time trying to actually narrow down this huge number of questions we have. And so the quiz today has 21 questions, I believe. And it's as fastest finger first is an element of it. So if the same people get the same number of questions right, the scores do take into account how quickly you press the answer. So bear that in mind. I believe there's 20 seconds for each question, and you don't get to see the questions in advance because the software won't do that. Which is why I've made it 20 seconds instead of a bit shorter. So, is everyone who wants to be signed up, ready to go? You should be able to do all the answering from your phone. Okay, let's see if this works. Things on there are still moving. Do they just move, or are people still signing up? We're gonna start. Ready? 3, 2, 1. Which one of these C2SP specs does not exist yet? T-log tiles, T-log witness, T-log proof, or T-log mirror? And then we wait. Okay, 45 votes. Oh, one in right at the last minute. 45 votes. So, and this is the breakdown. This is what this software does. It shows you the breakdown of who answered what. And the answer was T-log proof. So now we will see how people did. Filippo. Good. That question was based on Filippo's keynote, so everything is as expected. Continuing to the next question. Ready? Which of these log failure modes has never been fatal? Unincorporated SCT, inconsistent SDHs, MMD violation, or data loss? Oh, only 44 votes. Does that mean someone missed the time? So the majority of people got it right. MMD violation. Logs have been in violation of their MMD, but they've never been cut for it. Thank you to Andrew for that information from his talk. So where are we at now? Ah, Winston has taken over. Oh, where is Filippo on this list? What happened? Onwards. Ready? What is Chrome's CT log compliance monitor called? Prolog, monolog, dialog, or soliloquy? This is where you start to see where we had fun with some of the answers. Actually, yeah, quite obviously, because no one went for, I really like soliloquy. The next thing I write. And the answer was monologue. Well done to the majority of people. Andrew's storming ahead. Well, there's a three-way tie at the moment is actually what that looks like. Okay, next question. Which platform was negatively impacted by adding static CT logs to Chrome's log list? Was it Chrome, iOS, Windows, or Android? Oh, some deliberation going on. But the majority of people did get it right. It was indeed Android. Things still looking quite similar at the top. We'll see how it progresses. What does BIMI stand for? Brand indicators for message identification, brand images are materially important, big images more information, or bold indicators of message importance. I have to not laugh during the ones that we found very funny. Well done, everyone. Good team job. Brand indicators for message identification is correct. Oh, but some people got it faster than others, and things have changed around a bit. Okay, in which version of Android is CT support available? 15, 16, 35, or 36? Yeah, we put a sneaky 36 in there to throw you off. 16 was indeed the right answer, but 36, I think, was the API version. We thought we were being clever. This is who's at the top now. Keep an eye on it. We've still got plenty of a way to go. By which day will Dennis's HelioTorrent project definitely be done? Was it Monday, Tuesday, Friday, or Sunday? Should have put that. Oh yeah, damn. Yeah, this was one that Rasmus referred back to, I believe, in his talk. The answer is indeed Monday. It's a weekend project that will definitely be done by Monday. So some of these questions will test just whether you were listening in that particular talk, not necessarily technical details. So moving on. What question are we on now? I don't even know. We'll find out. 8. Which of these common log challenges does Tessera not address? Reliability, decoupling of reads and writes, deduplication, or filtering of data? Yeah, we changed the names a little bit, so you had to have an understanding of the talk. The correct answer is indeed filtering of data. And with the question about his talk, that has bumped Philippe to the top of the leaderboard. Okay, onwards. What is the code name of the latest MTC proposal? That's Merkle Tree Certificates proposal. Is it sunlight, photosynthesis, sunglasses, or plants? I mean, it's not surprising that each time the majority of people do get the answer right. I think that's a good sign. It was indeed photosynthesis, but these are all terms that were maybe mentioned in that talk, but have definitely been mentioned during this conference. So I'm trying to make it a little trickier. Okay, we've had a bit of movement in the leaderboard. Philippe, not fast enough. Which of these does Tilitis HSM not build upon? Tiki, USB Armory, Cryptech HSM, or UBHSM? Who was paying attention to that very specific slide that I took a photo of? Okay. Yes, again, majority got it right. It was indeed UBHSM. The other three were all used in the design and development of Tilitis HSM. Here is where we are standing. You were right. Like Philippe did get that the previous one wrong. Anyway, not that it's all about you now, but everyone's watching. Next question. Confidential computing for witnesses reduces the need to trust witness operators, hardware vendors, software developers, or cloud providers. This is one where I really hope we got the answer right, because in this case, is Adit here? No? Okay, well, hopefully this is right. This is the first one where the majority did not get it right. The answer is witness operators. I know. Oh. That has rejigged things quite a bit. What does WAKT stand for? Web Application Information Control Transfer, Web Application Integrated Cryptographic Toolkit, Web Application Integrity, Consistency and Transparency, or Web Applications in Consistent Trees? Oh, you're all too clever. Oh, did someone vote for it just to make me happy? Yes, indeed. It was Web Application, Integrity, Consistency, and Transparency. We really enjoyed it. This is actually thanks to Martin, that final Web Application in Consistent Trees. That made us laugh a lot. So there's where things are at now. Oh, people think, yeah, the timer is going to play a part, isn't it? Okay, next question. Remember, you've got to be fast to get those points. With Gopher Watch, what can you look up via DNS? The latest version of the Go module, all versions of the Go module, all allow listed Go modules, or the Go module policy? Wonderful. Yeah, so a bit of a split on this one, but it was indeed the latest version of the Go module. The Go module policy, we made up. We don't know what that is. Rasmus said it, and I was like, that sounds good. And then he was like, no, that's not a thing. We don't know. Anyway, if someone does know what that is, then we've stumbled upon a plausible answer. Okay, next question. What is the collective noun for a group of owls? Is it a council, a government, a parliament, or a congress? Who was paying attention during Hayden's talk? I'm quite pleased that not everyone got it right. That makes me happy. So even if you are one of the people that didn't get it right, if you were doing it for lols, great. If you weren't doing it for lols, you made me happy. So it's all good. The answer was indeed a parliament of owls. Winston's still going strong. Andrew's not far behind, though. Winston's just got to get one wrong, and could be even Stevens. Right. Next question. Question 15. What is source epoch date in the context of reproducible builds? Is it the time of the first modification of the source, the time of the latest Git commit, the current time, or the time of the last modification of the source, all in seconds since the Unix epoch? Yeah, the time goes fast when the questions are long. It was indeed the time of the last modification of the source in seconds since the Unix epoch. Things are still looking similar. These top few, they just know their stuff. Or, well, they've been paying attention, which is what we want. Next. Which of these is not an entity in digital ID systems? The holder, issuer, verifier, or authorizer? Good job, it was indeed the authorizer. How are we doing? Oh, things are still there. Winston's just like on it. Okay, only a few more. Which flavor of Go is used by Boot Transparency? Tiny Go, Tamago, Tobago, or Time to Go? We really enjoyed this one. I told them I was going to try and say it with a straight face, but I have failed. Yes, correct. It was Tamago. Tobago is an island. And there are no... It's a name for a Go thing, potentially, because it doesn't currently exist in the realm of Golang. Yeah, still looking very similar for the top 5. In Ent, what is content addressed by? Location, publish time, hash, or leaf ID? An overwhelming number of people thought hash, and you are, in fact, correct. Well done. Looking the same again. Hoping there's one at the end that might throw people off. We'll see. Okay, which of these does not currently have key transparency deployed? Proton Mail, iMessage, Signal, or WhatsApp? This was fresh from today, so hopefully it's still right there in your mind. Yep, it was indeed Signal, although we did have it mentioned that Signal are currently looking at it and working on it. All of these were mentioned during Melissa's talk and the questions. Oh, Winston and Andrew still at the top, but there's been a bit of a shift in the third, fourth, fifth. Whoever is smiley face has gone down one. What happened? What happened? Maybe it was a timing thing, actually, though. It could have been a timing thing. Be faster. Okay, I think we have 2 more questions, so in it to win it. What is anonymous witnessing based on? A cryptographic lottery, a distributed hash table, a fixed set of trusted witnesses, or Tor onion services? People were paying attention this morning, weren't they? Well done. Cryptographic lottery is correct. Okay, our final question for the ultimate chance at the incredible prizes we have. Oh, this is how it is, sorry. Got ahead of myself. How many T's are there printed on the front of the Summit t-shirt? Is it 67, 84, 90, or 101? Isn't it annoying that you don't have time to count them? Do you know what I spent yesterday evening doing? Did it 3 different times in 3 different orders to make sure the name ended up the same, the number ended up the same. But well done. I mean, yeah, the majority of people, well, not the majority of people, but the largest amount did get it right. It is indeed 84 Ts. And that includes the T in Transparency and the T in Summit as well. Okay, so, well, no, wait, thank you. I'm like, no, not yet. Okay, so final leaderboard time, and then Rasmus and Adonna, do you want to come and help give the prizes? Da, 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 Winston held on. Oh, Andrew, though, no, you got bumped. But luckily, second and third prize is the same, so that's fine. Can we have Winston, Gregoire, Andrew, oh, you're going to make me pronounce your name again, Michael and Frederick to the stage, please. Give your winners and second to fifth places a round of applause. Well done, everyone. Okay, so Winston. Is this the order? Have you stood in the right order? I don't know. What does the thing say? Not quite. We know Winston is the first. A round of applause for Winston. You're going to be clapping a lot now. Who was second? Second was Gregoire. Andrew's like, no, not me. Well done. And for Andrew. And then fourth and fifth, I believe they are the same, but you want the one with the right number, don't you? Take the correct one. Shake the hand. There we go. Your winners. Amazing. Okay, so that's the quiz. Thank you, guys. What comes next? I believe, no, we have lightning talks next, don't we? So, yes, they've done that already. I'm going to leave this here. So, lightning talks. No, you know what? I need that open. Sorry. Can you keep it on that? I don't want this on there anymore. Yeah, perfect. Let me find the list. Okay, so unscheduled lightning talks. Where are we at with time? I just need to check all this. Usually there's breaks in between things. We don't have one today. I apologize for the rambling. We are perfectly on time. Good job, everyone. Okay, so our unscheduled lightning talks. We have 10 people. Filippo, I've added you to the is the 10th. Is that cool? 10 people who signed up for lightning talks. I haven't properly thought through how this is going to run. I think so. The order. Shall I just read the order out and then? Yeah. So Michael, you signed up first, so you will be our first. We're going to have Michael, then Linus, then Michael, Matthew, Imad and Abirami, if they're here. I know, are they here or are they come? Yeah, they're here. Maybe you can display this. I don't know. No. Klondike, Andrew, Florian, Sasko, and then Filippo. What I will do is give a microphone to whoever's on the stage, and then I'll have another one and hope that the next person comes up. This is going to be like not as smooth as everything else has been. Deal? Okay. Michael, would you like to come and give your lightning talk? Question for them. Can he connect to the screen? Yeah, pull that one out, put that one. Yeah,
I'll then have to,
yeah, no problem.
Oh,
Nothing broke. Yeah, if you take it out.
Yeah, thank you. So I made 2 slides because I have 2 projects that I wanted to show. So one of them is Go builds. This is, I think, 6-year-olds now. It does reproducible builds for Go. So maybe you know that the Go compiler can cross-compile reproducibly. That's a nice feature. And so I built a small service that will build on demand any Go module, any source code for any version, for any toolchain version, for any platform like operating system and architecture. And then calculate a hash and put it in its transparency log. There's some limitations. You cannot do CGO because that makes cross-compiling reproducibly quite difficult. But the idea is here that then you can trust this service maybe to provide you binaries for any source code. And yeah, there's some trickiness. Do you want to be downloading binaries from this service? Do you really want to trust it? So I think due to the transparency log, and you could verify it, it could be trusted. So let me see if we can open it up. show it real quick. Oh, yeah, yes. Okay, got the wrong link. Let me. This first one. So this is the website. You can see a whole bunch of recent builds that have been done. You go just to this one. Oh, we will actually build one on demand now because it wasn't opened yet before. There's a way to, I give you a command to download this build with verification through the transparency log, because you can download these binaries from the website, but of course then you don't get any of this verification. And right below here you can switch to any of the older versions, any older targets. So you can see this one has been built before. We've got a check mark, we've got a hash. So this is the hash of the binary that's in the transparency log. And there's like a quick thing that you can check that's the same. You can download the binary and see that you get the same hash. All right, so that's like one project to actually I created this so I wouldn't have to provide binaries for my open source projects. I could just point to this page and say, just get your latest binaries here compiled with the latest Go toolchain. So that's been somewhat convenient. Because as you know, maybe the runtime and the standard library is always included in these Go binaries. So when anything like a new Go toolchain is released, you ideally want to update your binaries. So then there's the second project. It's called IceGo. It's for automating Go apps that I've deployed. So I run a bunch of my own services, not very important. I wouldn't necessarily recommend this for important production use. But like updating your applications all the time can be a bit of a hassle. So I created IceGo. And so instead of directly running your Go application as a service, you let IceGo run it. And at startup, it will check which Go module it's starting, because that's in the binary. And it will look at the version of the module itself and of the Go toolchain that it's compiled with. And we'll use this DNS server in GoverWatch to very cheaply check for updates. And if there's an update, we'll go to my build service and fetch a new binary, because I kind of trust it and I verify that this binary is the right one I'm getting. Then restart the application. So that way, I always am running the latest version of my application, and I'm compiled with the latest Go toolchain, with all the fixes included. That's so what all these slides are about. So this can be a bit tricky. You don't have to do it automatically. You can do just the one-click update, just to make it easy. There's a web interface. You can configure a policy that you don't want to immediately update, maybe wait a few days. You can also configure that you only want to do patch updates, not just any update, because that's probably not safe. You can also configure when you want these updates to be done, like during work days or in the evenings or whatnot. So also open source, check it out. And I don't know if I'm way over time or, well, good, there's no time. Let's happily hand over to next. So if you have any questions about this, probably come talk to me after.
Yeah, we won't be doing questions during the lightning talks because it's lightning.
Yeah.
But after, we're going to have chats. Thank you, Michael. Linus is next. Could we have Michael here to do? Yeah. I'm going to announce the next one each time. So if Michael can come up.
Thank you.
Hi. I don't have slides because I promised to not have slides. This is going to be about Tor consensus transparency, so I will give you a very, very short intro into what the Tor consensus is. It is the document that defines the network for the next couple of hours, and there is a small set of external auditors, as Elena would put it, 9 of them who are voting for the next hour's consensus every hour. So these 9 define the network, and the clients download this map of the network and do source routing through it. So an attack on a client would be to serve them your consensus so that you can put them to your relays, if you're operating relays, and then you could de-anonymize the user. So this is like the trust anchor of the Tor network. So they're important, and majority out of 9 would be 5, and getting control over 5 keys, or at least getting a signature from 5 keys, is not an unreasonable thing to do. So the idea has been for a long time to do consensus transparency, for some definition of consensus transparency. And just a week or 2 ago, we were couple of people who met together and with a lot of Tor people, and we came up with the idea that this could be done very easily. So I did a proof of concept of that in Bash so that everyone can read it. And the conclusion is that it is easy to do transparency logging. I'm using SIGSUM because that's what I know. The hard part is, of course, monitoring. And so all the other things are, if you know computers, they're easy. But the monitoring is like, oh, you need some sort of database format, and you need some way of conciliate or compare lists. So you watch something, you visit some website looking for something, you look at some logs, and reconciling this is the tricky part. And the most tricky part is to come up with the message and the destination for that message that is actually actionable for anyone. So if you want to do some sort of transparency logging of any kind, I would advise to start with what kind of messages would you like to send that could be useful for those who can do something about this. And because that starts the process in the right direction or in the right end of the problem, I would say. So think about an email that can be sent. What should that email say, and who should receive it? At least that has been helpful for me. In this case, we identified 2 types of transparency that could be useful here, and the first one was key user transparency, obviously. So the 9 directory authorities, the operators of these could actually see publicly available and hard to tamper with list of when their key has been used. So if someone would break into their system and sign a false consensus and use that somewhere, you would see that there was an extra signature being done with your key, and that could be very useful. And the second thing was something that we just dubbed archive transparency, because there is an archive of all the consensuses and votes back in time on a simple web page. There's a web server serving them up, but that archive could be compromised, and lots of research is based on what we find in that archive. So being able to keep the archive honest is another application of this. I have some Bash code somewhere. That is not the interesting part. I built the monitor on top of Florian's Sigmon, which is a very nice and easy to get started with log follower, so to speak, where you can have hooks doing whatever you want to do when you find a new entry in a log. That's about it. Thanks.
Hi, everyone. I'll keep this quick. I want to make a blog post describing what transparency is and isn't. I feel like I've spoken to people who are, cryptographers, who are extremely skilled engineers who still don't have a really strong idea of what transparency is. The current idea is like transparency is 3 things: a global log, a monitoring story, and client-side enforcement. And you need all 3 of these legs in order to get what we think of as transparency. So I just wanted to ask y'all to come up to me, and I would love to hear examples of things that aren't that. Like examples that you have in your head of where one of those legs is missing. I've been asked a lot of times to sprinkle some transparency on some random stuff. And a lot of the time that makes no sense. I'm sure a lot of people in the crowd have had similar experiences. I would love to have a thing that I can point to be like, that makes no sense. Here is why it's missing leg number 2 or leg number 3. So find me.
Sorry. This takes time.
So, I'm here to talk about you. Not awesome. Oh, yeah. That. that's very okay. So digital archive transparency. I'm here for free, mostly on my free time, and I feel like there is not much brain power spent on digital archives yet, and I feel like I have access to a lot of brain power here. So why it's important, digital archives? This is becoming part of the critical infrastructure. We all care about keeping stuff online all the time, but at some point stuff will break, the world changes, and we turn to the web archive, to National Archive, to other third-party repositories for documents, and then we try to get them to provide a proof of past provenance. We just ask questions as, can you tell me that this comes from the past? We had an example this summit with the BIMI guys using the web archive to check that the brand existed in the past. And well, as we are like building trust models, including the archives inside, we are going to have bad actors trying to target these trust models. And the side effect of a bad actor targeting digital archives can be like problems recovering the truth of history, because you cannot distinguish backdated metadata from legitimate past. So the only fix is now trying to get some signatures inside digital archives. And here I feel like the transparency is not a magic fix because it has a global state. But in some ways, digital archives have a very good monitoring story. We just want to check that we don't have backdated entries inside our archives. And in that way, this is for now mostly an ID. I'm trying to build a prototype. I'm trying to have a good case. So when we come forward to the archiving community that don't have a lot of engineering capabilities, we as like cryptographer and security minded people can like bring a simple enough solution, like saying, look, we have built something that can be very useful to you. So yes, I'm asking for your help. If you know people in the archiving circles, maybe go talk to them about transparency, or yourself think about the problems that they have about authenticity of proof of past provenance. And also, if you want to talk to me, search for the website. The only result for the keywords digital archives transparency, because we may need more people working on that. So yes, please reach out and have fun. Thanks.
Morning, folks. I'm going to try and keep this quick as we can. Let's see here. Oh, it's funny. The only person running Windows has problems. Weird. Let's see if this will fix something. No. Oh, there we go. That actually works. Go figure. All right. So we've been implementing remote attestation, and more specifically, we've been doing it using homomorphic hashes. And here's some lessons on how not to use them. So you may be wondering, you're using what for what now? Remote attestation, for anybody who doesn't know, is basically a mechanism by which a trusted entity, a verifier, issues a challenge to an untrusted prover. The verifier can then check the prover's response, and compared to a known safe state, they're determining the integrity of the prover. Homomorphic hashing, meanwhile, is an approach that allows for operations on hashed data. So if we have a hash that's B and C combined, we can then add hash D to it, or then we can remove hash B, so on and so forth. Using the two together, and at least what we believe, is that it allows for scalable, dynamic, and fast attestation across large-scale networks through hash aggregation. I'm not going to speak more in detail about that. Ask us later if you want to know more. So what did we learn the hard way? First, you really need to understand the problem that you're solving. Remote attestation and homomorphic hashes are catch-all phrases. It's kind of like saying, well, I'm going to use encryption. Implementation details can vary wildly. The purposes that you use something for can also differ wildly. You need to understand what problem you're solving and what your adversary model is. For example, in the case of homomorphic hashes, in quite a lot of the different implementations, it's very costly to remove elements from a hash. So why are you creating a solution that needs removal then? Think about what you're doing. Second one, my personal favorite, keep it simple, stupid. Homomorphic hashing has a wide range of fantastic use cases. Again, ask us if you want to know more. But just because you can doesn't mean you should. For example, early on we were thinking of, well, we can use this to ensure confidentiality, integrity, availability, all the standard security features. But then we kind of realized, should you? History has kind of proven that making your own cryptographic protocols is usually a pretty bad idea. Don't do it.
Hi. One more lesson when now isn't really now. Like homomorphic hashes, it sounds like a magical words. It can we can aggregate data quickly, and also you can verify all at once. But in practice, it's come up with a lot of real constraints, such as for instance, you may think about the order of events, the timing context, and also you can think that. What if, and also you can think about the timing matters, because while thinking about the real constraints, it also brings that trust isn't only about the data being correct, it's about it's being correct. This comic nicely says that the time keeps moving, even when the system assumes it doesn't. So broader perspective of this is you have to understand the technology constraints. So all of these lessons reminded us remote attestation gave us the foundation of trust, and homomorphic hash gave us scalability and also efficiency. So together these both give us the trust and the scalability nature, and also what else? And also it's give us it also a journey from math to a meaning, I would say. Yeah, thank you.
Thanks a lot. If you want to get in touch with us, there's the links. Thanks. Oh, careful. Tearing down the stage already.
Oh, yeah. Let's make it safe for people. On the other side, you don't need to use that. That one.
Yeah, thanks. Amazingly, it seems to work on the first go. There you go. So I'm going to introduce you a really tiny cryptographic kernel. It's called FemtoCrypt. It was originally called TinyCrypt or MiniCrypt, but we had an amazing conversation during dinner yesterday, so we decided to change the name. Who knows this guy? This is the Justice Minister of Denmark, and he has pretty literally said that, well, apparently communicating over encrypted messaging services is not supposed to be a cyber liberty, and this is something that they need to stop people from believing. The geopolitical situation is not much better. I mean, anybody who is checking the news knows that most West world democracies are moving more towards the right. Chat Control 2.0 still has many supporters, despite it has been stopped. And yeah, as you saw, some decision makers are even trying to consider the idea of banning encryption. The good thing is that this is not an old problem. I mean, there are quite a bit of nice solutions that we have found in the past. In the 80s, getting a floppy disk was usually hard, and distributing them was very, very hard. So what did we do? We just wrote code listing on newspapers or went to demo parties where we could use exchange data. On the 90s, it was impossible to export cryptography out of the US. What did we do? Well, we are going to export books. On the 2000s, using a strong cryptography was hard, exporting it especially. What did we do? Well, we decided that, well, hash functions, you said that okay, right? Okay, we are going to make cryptography using only hash functions. So as you see, we have most of the building blocks that will make this cool thing happen. So preparing for the worst possible scenario, that was before chat control actually was stopped, I decided to make a kernel that allows end-to-end encryption, that can run all set of messaging apps. So if you prevent end-to-end encryption of messaging apps, you still can perform end-to-end encryption by just encrypting things before you send them. Only using standard library functions from Python, in this case. Producing messages that are indistinguishable from random noise, so you can actually hide the messages on images or, well, I have a few other ideas if you want to discuss them after the talk. And with as tiny code as possible, because obviously whoever who has to use this will need to type it or get it into the computer somehow, and we want to make it easy. How small can we go? Well, the answer is around 493 bytes. You have the code on the right, that QR code you see over there, you can scan it. It will give you exactly what you need to do end-to-end encryption. How does this work? Well, we use Diffie-Hellman. We use a safe prime that is tiny in comparison, that's due to a big power plus a small value. For the smallest possible value that we could find, that still meant that followed all of the properties we need for Diffie-Hellman to work correctly with 2 as a generator, because 2 is also a tiny generator. We use a hash function to extract shared key entropy. We use a hash function of the key in order to generate the one-time path. I mean, all of these are pretty reasonable building blocks nowadays. Everybody should be familiar with them. So the one-time path is as simple as just having a counter that is appended at the end of the key, and we just return the hash of that to get the one-time path that we use for encrypting our messages. This is indistinguishable from random data, which means that the XOR is indistinguishable from random data. Now about the keys, that's the cool thing. Because we are using a relatively tiny B value, we can just discard any keys that will have more than 4096 bits. Which means that all of our public keys can be 4096 bits without losing any security. And because that's supposed to be, the public key is supposed to be indistinguishable from a random election out of the wall, possibility of, out of the wall list of numbers that you have modulo P, well, that means that the public key and the private key, which is also random, are completely indistinguishable. Encryption is as simple as just generate an ephemeral key, calculate the shared key using the hash of the Diffie-Hellman exchange, and then just XOR the message with whatever one-time path, appending the key at the end. The encryption is pretty much the same, but the other way around. We extract the public key, and then we just do Diffie-Hellman with our private key. Future work, how to use this with key transparency, so we can actually have like a public database of keys to communicate. Can we also add message authentication in less than 512 bytes, so the whole thing still can fit in a single disk block, so it's easy to just get rid of the code if something goes wrong. And, well, maybe we can even implement steganography. Thank you.
Yeah, so a few years ago, the Go project added a really cool new feature to Go 1.21. If you try to build a Go project that depends on a newer version of Go than the one you have installed, the compiler will automatically download that new version of Go and use it for building that project. It's a great feature that provides a great developer experience, but hang on a moment. The compiler is now downloading and executing binaries on the fly? Well, that makes some people nervous. So the Go project did 2 really cool things. First of all, they began publishing their tool chains in the Go checksum database. This provides assurance that everyone is downloading and executing the same binaries. And second, they made those toolchain binaries byte for byte reproducible from source. This ensures that the Go project can't hide backdoors in the binaries. This is really cool. But it only means something if people are actually verifying these properties. So I decided to become one of those people, and I created SourceSpotter. SourceSpotter tails the Go checksum database, and whenever it sees a new version of the Go toolchain in there, It downloads the source code, it builds it in an AWS Lambda, and computes the checksum of the resulting zip file. And if that checksum doesn't match what's in the Go checksum database, then SourceSpotter will raise an alarm, I'll investigate, and if necessary, I'll send one of my emails saying, what's going on here? A couple other things that SourceSpotter does is it provides an API endpoint where you can upload checkpoints that you've seen from the checksum database, and SourceSpotter will audit those. I have all my Go CI jobs upload the checkpoint to this API endpoint. So if the Go checksum database ever serves a split view to my CI jobs, it'll be detected. And then another cool thing about Go is that they publish the configuration for their telemetry in the checksum database. So SourceSpotter downloads those configurations, and then it displays on a web page all of the various telemetry counters that the Go telemetry is using. So people can look at this page and make sure that the Go telemetry isn't uploading any private data. SourceSpotter is open source, and you can learn more at sourcespotter.com. There are some dashboards there, some RSS feeds where you can monitor if there are any failures with the reproducibility, or any new counters are also published there. So yeah, thanks guys, everyone.
All right, I'd like to talk to you about certificate transparency for SSH certificates today. So if you're not aware, SSH certificates are a mechanism where instead of distributing your authorized keys files to various servers, you can just distribute a CA key and sign your user keys using that CA key and log into your servers using that. But this is kind of familiar now. You've exchanged you get the usual problems you know from web PKIs. So you've exchanged the distribution problem of public keys for the distribution problem of distributing CRLs. So for that you can do short-lived certificates, for example. But how do you know that the CA hasn't been taken over by somebody who now issues long-lived certificates, maybe for your root principle, in a way that you could never find out about it? A solution for that, obviously, is use a transparency log. So how can you do that with SSH, which has no awareness of transparency? So SSH certificates can include arbitrary extensions, where you can, for example, shove in a inclusion proof. But then you need to verify that on the other side, and you'd normally want to do that without touching any of the nitty-gritty OpenSSH authentication code. And for that, the OPK SSH project, which does something related, namely OpenIDC authentication for OpenSSH, they have figured out a neat trick to do that. Namely, there's this authorized keys command in OpenSSH where you can dynamically generate your authorized keys file based on the current login attempt. And you can get stuff like the actual certificate somebody's trying to authenticate with. So the trick you can do is look at the certificate, do some processing on that, and if you like the certificate, output a matching authorized keys file, otherwise just output an empty file and the login attempt will fail. So the game plan is have a CA that generates a pre-certificate without a signature, submits it to a SIGSOM log, take the proof that results from that, stuff it into an extension, and then sign the cert because we still have to rely on the regular OpenSSH mechanisms. And on the server side, take the proof out of the certificate, verify it, and if we like it, output a matching authorized keys file. And if not, don't, and the login attempt will fail. And crucially, this never touches any of the critical authentication code, so it's never worse than just doing certs on their own. So I have a quick demo of that. That's going to be a little bit tricky with the microphone. So on the right here, you can see a random VPS on the internet. And there I have configured in the OpenSSH config this authorized keys command with a little Go tool that does all the verification I just described. And if you look into my home directory, you can see there's no authorized keys file there, but this CT directory, which has a number of files, in particular a SIGSOM policy. And if I try to log into this machine, it fails because I don't have a certificate. So now I can go to my little self-service SSH CA that incidentally also works over SSH and tell it to give me a certificate. So it's going to talk to SIGSOM, submit a proof, give me back a short-lived certificate, stuff it into the right place for the client to pick it up. And now I can look into the machine, hooray. And you can already see on the bottom right here, I'm also running a little Sixer monitor that closes that loop, and it looks for new entries signed by that key. And whenever that happens, it goes to the CA, asks it for the certificate, and sends me a report. And if I get a report that I didn't ask for, or if something is fishy, I can do something about that. And here you can see the certificate has this big blob, which is just a 6-improve in ASCII compressed with zlib, so that it's not all that huge. So this enables me to detect if somebody has maliciously taken over my CA, issued a certificate I didn't want to have, and then I can go investigate. Thank you.
Hello, everybody. I'm here to talk about our journey of setting up a witness. We started during summer to try out, and also when we want to set up a witness, of course, we want to use the T key, and there is no implementation with that. But we had our friends from Glasklar as a starting point, and we started with their setup, and then quite easily changed from UBHSM to our T key using SSH agent. We had to recompile because this is a USB key, you have to touch it to sign. We had to recompile and remove the signing, and then we set it up during summer, and this is our lab witness that we have here. During the last couple of weeks, we have done this in production. So since last week, we have a production witness up and running with our T key and Raspberry Pi.
It is me again. Drum roll.
Oh, ta-da.
Screen mirroring. Aha. Mirror this window. Yes, great. Okay, so real quick. It would be a lot of people want to do analysis on CT data. There's a bunch of interesting stuff to find there, but also CT log operators are not really in the business of running CT logs forever. Like we really are not. Those things get big. So right now we essentially have logs just getting turned down, and mostly just Google running mirrors. That's not really a long-term solution. So when talking about this on Blue Sky, somebody from the Internet Archive was like, well, we have lots of archive. Like, I can't comment as to running services or anything else, but space. So I figured I would do the engineering for them and just put together something to archive T-logs. This is for static CT API, but really I think it's a bit of a blueprint for how to archive any T-logs. What it does is that, so the nerd fun part is that it takes the tree, it splits it into 16 million chunks, which happens to align with a level 2 tile, because 256, 256, 256. So each chunk will have one level 2 tile, all of the tiles below it. And then we put that in a zip file because we want the thing to just be accessible for a long time in the future. We also tried like fancy zip, like zip with ZSTD, and it was like 5%, not worth it. So it puts in there also a README, a checkpoint, a JSON specification of the log, all of the issuers, and the higher level tiles, and the tiles on the right edge of the tree. Why the ones on the right edge of the tree? Because given those, the high level ones, and one of the subtrees, you can compare with the checkpoint and actually verify the signature from the log public key on the checkpoint for each zip file. So each zip file is self-verifying, even if you haven't downloaded the entire log. You can start by downloading a single one and start reading arbitrary entries from that zip file, because zip files are seekable. So realistically, you can just point a client at this set of zip files and just fetch entries like you would fetch from a live log. So it works. There's an announcement. Well, that didn't work. Okay. There's an announcement on CT policy with links, including a pull request with the code and encouraging comment from Matthew. I truly appreciated it. I saw the email shop. Oh, nice. There is only one nit. So, for some reason, I started uploading the zip files to the Internet Archive, and for the last one, it told me unacceptable content. Well, shit. You know, we've had issues with content and CT logs, so I was kind of worried. What have I put on my hard disks? Will I have to just like shred them? Okay, so I bisected the size of the zip file, because if it was just one file at the end of the in the last zip file, it would upload. All of the files not upload. Okay. Did the binary search, you know, used binary search, doesn't happen often, and found a specific size at which it would go from from acceptable to not acceptable. And I could find nothing in that file. So I pull it out, and it uploads. I put it back in with a different CLI tool, it uploads. I have no idea. I decided it's a fluke. I uploaded the thing that finally uploaded, moved on to the next log, different years. I upload all of the things. I get to the last zip files. Not acceptable. There is nothing in common between those. So if you want a nice murder mystery, please fix this for me. I have no idea. Truly no idea. We are getting no feedback from the error message. I don't know. It's in the email. Help.
Amazing, thank you. I do think it's kind of wonderful that we both started and finished with Filippo. There's a nice symmetry in that. I'm just going to move this cable so that I don't end up falling over. Okay, so that is all we have for you in terms of Summit Conference. I hope you've all had a wonderful time. I have. It's been really fascinating, some incredible talks. There seems to have been a lot of really good discussion going on as well, so I hope you've all got lots to think about and have maybe made some new collaboration connections as well. A few things from me before I hand over to Frederick to close. Reminders, if you can send any selfies or photos you have of people here with Cardboard Martin to me, that would be much appreciated. You can send it via email or you can send it via Slack. A few people have asked me about the videos of the talks being on YouTube. So the live streams are up. They are, all, well, still going up, I guess. They're all up there. They will stay up there. Obviously, it's a long, full day thing each time. So your talk is up there, but it's in a big, long live stream. We will be, our wonderful production crew will be giving me the videos of the live streams, and I will cut them up and upload them. So we have the individual talks. Timeline-wise, I don't want to overpromise. So it'll probably be the next 2 to 3 weeks. Hopefully that's okay. I will send out an email to the speakers to let you know once they've been uploaded. If anyone is interested in hosting next year, let me know. This is the end of this one, and we start thinking to the future, to the next one. I'll be starting to think, again, I might have a little break, but then be starting to think about dates and what we want to do for next year. So if anyone is like, oh yeah, no, that would be fun to host, drop me a line, drop anyone on the Trust Fabric team a line, and we'll go from there. I will be sending out a post-event survey again in the next. That one I'll try to do sooner so that the feedback can be fresh in your mind. So hopefully in the next week. Please do fill it out. Any thoughts you've had about the conference, any constructive criticism, like what could have been done better, we like to hear positive things too, so what was great. Absolutely anything. We're keen to hear it because this is only the second one we've hosted, and each year will be a bit different depending on the hosts and the venues that we have and the budgets that we have. But we do, if there's structural stuff or anything to do with how it was run that could have been that better, that could have made it more productive or more enjoyable for you, please do tell us, because we want to improve year on year. And yes, I think that's everything from me. So I'm going to hand over to Frederick, who is our wonderful host, to close up the event.
All right, that was a fantastic summary, so I'm going to keep this short. Okay, I would like to start by thanking our sponsors. I would like to thank our production crew from Informationsteknik. This is the first event that I've been part of arranging that includes live streams and this kind of video setup, so I was quite nervous, but there have been no problems or hiccups whatsoever, neither with audio or video or with anything else that I'm aware of, which feels fantastic. So to all of you who are considering hosting the event next year but might be worried, seriously consider hosting the event. It's quite fun, actually. I would also like to thank my executive assistants, Anneli and Marie, who, among other things, on short notice, managed to get Martin all the way here from the UK. Speaking of which, I would also like to thank the program committee and all their hard work in soliciting talks and all of those things. So thank you so much. And last but definitely not least, I would also like to thank Kat for arranging and hosting and organizing before and during the event. Thank you so much. And well, I realized I need to thank you as well, because thank you for attending, thank you for creating this, making this event as fun as it has been. And I have to say, with Kat's 2 years ago at ACM, CCS, and last year the first TDS, and now the second one, it's amazing how a lot of you I had never met before, and now it feels like we're really starting to form quite an interesting and coherent community. And I'm really looking forward to seeing as many of you as possible next year, wherever and whenever that is. So thank you so much, and I guess this is it. Yeah, see you next year.